Hello and welcome back. I am excited that you decided to join me on another little adventure. Today's adventure chapter is called Use Cases. So let's see, what are we going to do today? We're going to get started with looking at the assigned reading, which was Object-Oriented Analysis and Design with Applications, written by Grady Booch, and specifically the chapter 1 of that one. That's what we'll jump in with. Then we'll look at use case overview diagrams as well as use case scenarios. And then in the end, as always, a little exercise, plus a checklist of how do you check whether your use case is good. First things first, let me introduce you to Grady Booch. Grady Booch is somebody who has been in the domain of software engineering for a very long time, well-known researcher and industry practitioner, has done a ton of podcasts and written articles, and I've seen him speak a number of times. He is also very active on Twitter. And one of his quotes that I like most, and it just happened to mention today again, was every line of code has an ethical and moral implication, which means that we software engineers have the long-term responsibility for the systems that we build. I fully agree with that, and I find it very, very important, and it's going to come up throughout the course a number of times. He is also the father of UML. That's why down here you already see the UML logo. He's been around since '55. He is an American software engineer, best known for developing UML, along with Ivor Jacobson and James Rumbaugh. He's recognized internationally for his innovative work in software architecture, software engineering, and collaborative development environments. Thanks, Wikipedia. And his homepage on the bottom left you see is computingthehumanexperience.com. Super interesting page. Go take a look. It's really worth checking out. Also, Grady is a wonderful human. He is one of the introverts among us, and another thing he tweeted that I thought was worth mentioning here because I love making people visible in their humanness, not just in their super clean and sleek professional image. So he quoted this picture, "You know you're an introvert when you need alone time in quarantine." He says, "I feel heard." So for all of you introverts out there, you're in good company. You be you. I think I'm somewhere in the middle. Don't know. Not entirely sure. With that, let's move on to object-oriented analysis and design with applications. I think this is my favorite picture of Grady because he has this fun smile. It's just really warm. So he starts his book off with the following paragraph. A physician, a civil engineer, and a computer scientist were arguing about what was the oldest profession in the world. The physician remarked, "Well, in the Bible, it says that God created Eve from a rib taken out of Adam. This clearly required surgery. And so I can rightfully claim that mine is the oldest profession in the world." Apologies. No, back. The civil engineer interrupted and said, But wait, even earlier in the book of Genesis, it states that God created the order of the heavens and the earth from out of the chaos. This was the first and certainly the most spectacular application of civil engineering. Therefore, fair doctor, you are wrong. Mine is the oldest profession in the world. The computer scientist leaned back in her chair, smiled, and then said confidently, But who do you think created the chaos? I love that Grady opens his book with this paragraph. I really thoroughly enjoy it. And it gives us a little glimpse on, inherently our task, our discipline is about dealing with chaos in one way or another. I'd like to put that on a business card as opposed to software engineer, master of chaos, or something like that. So we're going to take a deeper dive into this chapter. First chapter talks about the structure of systems, like the different types of systems that we can look at and how they're structured. And he compares the system of a personal computer, and plants and animals as systems, and institutions, social institutions, and then also the system of matter. And then he speaks about the inherent complexity of software. It's a given. Why? The world is fairly complex. So if we try and model part of the world and represent that in software, there is an inherent complexity in there. Then he gets to the 5 attributes of a complex system. And honestly, I'm blanking out on these 5 right now. It is hierarchy, structured hierarchy, then separation of concerns, primitives, relative primitives, common patterns, and stable intermediate form. With those 5, he says, well, how can we now talk about organized and disorganized complexity? And how can we bring order to the chaos? Well, for that, we use modeling paradigms. And then in the last subchapter, he speaks about the design of complex system. And how are we going to do that? Using UML. Using object-oriented analysis that can be written down using UML notation, to be precise. So the summary is that software is inherently complex. The complexity of software systems often exceeds the human intellectual capacity. And the task of the software development team, and I really like this part, is to engineer the illusion of simplicity. So we want to pretend that it's really simple, and we're actually hiding a pretty complex task from the user, but we make it simple for the user. Complexity then often takes the form of a hierarchy. It is useful to model both the is-a and the part of hierarchies of a complex system. The is-a is a generalization, one type of abstraction, and the part of is the object-oriented view on it. Complex systems generally evolve from stable intermediate forms. And there are fundamental limiting factors of human cognition, and we can address these constraints through the use of decomposition, abstraction, and hierarchy. Furthermore, complex systems can be viewed by focusing either on things or on processes. So I can look at the objects that are part of it, or I can look at the process flow of the steps they have to go through. And there are compelling reasons for applying object-oriented decomposition instead of algorithmic, which is more the process way. And in the object-oriented decomposition, we view the world as a meaningful collection of objects that collaborate to achieve some high-level behavior. Object-oriented analysis and design is then the method that leads us to an object-oriented decomposition. And object-oriented design uses a notation and a process for constructing complex software systems, and it offers a rich set of models with which we may reason about different aspects of the system under consideration. So we know by now we need a set of models. We need models that represent the different views onto the system, some structural views, some data views, some flow views, some state views. All of those are useful for different purposes. So I hope you enjoyed reading that chapter. I think he writes very well. The rest of the book is obviously worth reading as well. And with that, I want to recommend one more thing about Grady Booch. He also gave a really cool TED Talk, TED at IBM, Don't Fear Super Intelligent AI. So check it out on TED.com. I found it super interesting. And yes, it takes us well beyond what the course today talks about. However, it's highly relevant for all of our future. And as I said, he's an excellent speaker. Go ahead. Which brings us to the design habit for today. So remember the last one, keep the essence, focus on the essence. That was the last one we talked about. This one here is about the problem domain. It says experts draw the problem as much as they draw the solution. Because experts know that their understanding of the design problem and their understanding of its solution inevitably deepen and co-evolve as they design. The experts therefore draw the problem as much as they draw the solution. They move back and forth in between the two. They don't only ensure that both stay in sync, but also explicitly use advances in the understanding of one to drive advances in the understanding of the other. So for example, if I draw the map of the traffic here on the right, then I understand, oh, in conversation with the colleague of how we're going to get through this intersection, oh, there I need traffic lights, so better draw some traffic lights in there. And then that leads to the light also being included in the model. Then in another iteration, I may think about, oh, we may need some lanes in this intersection because otherwise we'll never get it clear. And so on and so forth. So in that way, you can iterate, and it means you just really have to go back and forth in between the problem domain and the solution domain and keep iterating. And analyzing the problem domain is as important as designing the solution. And today we're going to jump into that analyzing the problem domain further by use cases. So check out this diagram. What do you see? What are the elements that you can identify here? Let's see what we got. Gas station automation. So that's the whole scope of this example that we're talking about. There's a box. It has a number of bubbles inside. The box is called the scope of the system, and then the bubbles inside are your individual use cases. So the use cases here are purchase fuel, wash vehicle, purchase lottery ticket, validate credit, and print receipt. And then we have a bunch of stick figures on the outside. The stick figures are called actors. The actors all have different roles. So of course there will be a bunch of customers and not only two, but there is only one role customer and one role adult customer. And they can do different things. So every customer can purchase fuel. I'm a little nervous about there being no restriction whatsoever on when I can buy fuel. I don't think my 5-year-old should go out and buy fuel. But for purchasing the lottery ticket, it's very definitive. It has to be an adult. So you see that the adult customer is a customer. So there is a generalization in between those two actors. The customer is a generalization of adult customer, which means who of those gets to do more use cases? Does that mean that the customer gets to purchase a lottery ticket that way? No, the other way around. So the customer can only purchase fuel. The adult customer can purchase fuel because they are a customer, and they can also purchase a lottery ticket. Let's see further. What do we have on the right side? On the right side, we have a stick figure called bank, and then one credit bureau and one state lottery system. And you may ask, well, wait, those are not people. Why are they stick figures? Correct. An actor can be either a stakeholder, as in a person or a role, or it can be an external system. So for the complete external system bank, there is one representative actor because that bank has an interface with this one use case. It interacts with that use case. Same for the credit bureau. And then same for the state lottery system. So all those three are systems. And they interact with the validate credit and print receipt, because as we make a purchase from either one of those two use cases, we will have to validate the credit to see, well, I mean, this is assuming we're paying with a credit card. So there are some details here that are assumed and are not being made explicit in the diagram. Nobody would validate my credit if I go pay cash. But then again, in several countries that I've lived in by now, that's the rather uncommon case, and most of us pay with plastic money. What else do we see here? We also have a generalization towards that validate credit and print receipt use case. So purchase fuel and purchase lottery ticket are modeled as specializations of validate, credit, and print receipt. There are several ways of how you could do this. Because you could say there is a generalization, you could also model it the other way around. You could say purchase fuel and purchase lottery ticket include the use case of validate, credit, and print receipt. You see how on the top from purchase fuel, there is an extend that goes to wash vehicle. So I can purchase the fuel and I can also, in addition to that, wash my vehicle. In the way how it's modeled here, I cannot go to that gas station and only wash my vehicle. It looks as if it is required that I purchase fuel for being able to wash my vehicle. So pay attention to these fine differences. For most gas stations that I go to, I know I can also purchase a vehicle wash without fueling up my car. Not at this one. And I'm not saying that's wrong. I'm pointing out the difference to you. That means when you come back to me after the lecture and say, hey, the way how I did this exercise, is this correct? Then there is a pretty big chance that I'll tell you this is one possible solution. And then I'll give you a little scenario and say, what is possible with your diagram is to do it this way, but not to do it this way. Was that a design choice that you made? Or was that something that didn't occur to you in that moment? So that's the difference. While we are still in the domain analysis here, while we're trying to understand the problem domain better, understand that you're also making very early design choices. That means you have to be really good at interviewing your stakeholders, which way exactly that process is supposed to run and be accessible. Because otherwise, you may include or exclude versions that the customer wants. So I said something about includes, which is not on this diagram. Includes work similar to extends. And I just wanted to point it out on this diagram that same as the extends, the wash vehicle extends the use case purchase fuel, we could say both purchase fuel and purchase lottery ticket include a little sub-use case that says validate credit and print receipt. Because there is also some process before that, and then I could just include that other one. Both of those are okay options. Going to the next one. What's different here? What do you see? One big difference is one actor only. So you will find for different purposes that sometimes you have use case overview diagrams with just one actor, the one that is being looked at for that specific purpose, for the purpose of whatever stakeholder meeting coming up with a particular user group. And then you only want to focus on their use cases as opposed to modeling and putting all the use cases into the diagram that that system has, because that may be way too much for the user that you're trying to interview, because they're only concerned with their small slice of the system. So if we look at the receptionist here at the hospital reception, they can schedule patient appointments and hospital admissions. Both of those extend the patient registration. And then we have patient hospital admission, outpatient and inpatient. Inpatient includes a bed allotment. So here we have the includes. And then we have some file insurance, forming claims, and we can file medical reports. So quite a few use cases modeled with only one side of the actors. There's probably somewhere a database in the background that you could, in theory, put on the right side. Because you could say, well, the reception, that is one thing, but then there's also a database on the back end that will be accessed by other modules later on, say when they update the patient records on the station and things like that. So that is another design choice, whether to hide that within the black box or whether to make it explicit here. I love formal definitions. It's good to have one to get back to. So a use case is a series of system events triggered by an actor that leads to a result for the actor or to results. And then in contrast to that, because I often get asked, I'm like, wait, but use case, you said there are several use cases in here. Yes, each of those bubbles is a use case. So this is a use case overview diagram with several use cases. And then each of those use cases gets described in more detail in a scenario. And a scenario is an ordered set of interactions between partners, usually a system and a group of actors. So for example, the receptionist and the hospital reception system. The use case diagram then shows us a set of use cases and actors and their relationships. Those are the two examples that we just looked at. It defines clear boundaries of a system, and it also identifies who or what interacts with the system. An actor can then either be an individual or another system, as I pointed out, and multiple actors can be involved in one use case. So you've seen several use cases where you had multiple actors going back to one use case. For the gas station, for example, there was a customer, and on the other side, there was a bank and a credit bureau interacting. Multiple actors involved. Let's get back to the notation. So on the left-hand side, stick figure, there's your actor, and they have a communication association. When that's missing, I'm going to ask you, how do they ever interact with anything here? And then here, the elliptical shape, that's your actual use case. And then you have the system or system boundary, the subject of the diagram. That is pretty much all you need. And then there is a couple of special relationships like the extends and the generalization and the includes. But we'll get back to those. Right now, here is one more example, just so you've seen a plethora, thanks Wikipedia. This one is about serving food in a restaurant. So there is a waiter that can order food and serve food, and there is a client that is involved in the order food and in the eat food and in the pay for food. And all of these can be extended by ordering, serving, and drinking wine, and then also paying for it. And what is one other notational element that is new here? Actually, two. Yes, one is that you see that there is an additional writing or an additional label on the communication association between the waiter and the order food. That's called receive order. And for the client, it's called place order. So when there are several actors involved in one use case, it's useful to have these associations named to make clear what their relationship exactly is with that use case. And then the other thing that you may note is that the extends have if statements. So up on top, we have order food, and that can get extended by order wine. And then further down, every time wine pops up again, the extends applies if wine was ordered. So that is an option for putting guards in there. Very useful. One further use for use case overview diagrams that I found on an agile website that I thought was pretty cool was to do release planning with this. I think it was agiledevelopment.org. And they explained that they will sketch the boxes as opposed to the system scope. Well, it is essentially their system scope for a particular release. So the system scope grows over time and starts including more use cases as development progresses. Here we have a couple more notation details. A couple of them are repeat and a couple of them are in addition. So you again see the actor and a generalization of them. In addition, For the associations, the communication associations between the actors and the use cases, you see that there can be a multiplicity. Multiplicity. It doesn't have to be there. There are many diagrams that I've seen that are without, and that's okay. Just know that that is an option to put it there. When would you put it there? When it matters for your design. So for example, here for that airport check-in, for the security screening, it does matter that every passenger goes through one security screening, and there can be several passengers that go through the security screening at the same time. Check-in is also individual, but only once per person. And then we have both the includes as well as the extends relationship in between the use cases. So there's a group check-in, which includes an individual check-in, and then there's the baggage check-in that extends the individual check-in. With that, you're pretty much ready to roll, but I still have a few more things to offer that may be of help. And that's the descriptions. So overview diagrams, you're all set. Stash that aside until we get down to the exercise part. The descriptions, this is where it gets really interesting, because those bubble diagrams, yes, they require some thought, and yes, you have design opportunities, and so you want to make sure you use the notation correctly. And nobody will ever be able to understand that use case diagram if you don't deliver it with a description. If you were to give me this thing and I had never been at an airport, I'd have no clue how all of this works. And that's why we need the descriptions. What are they? So a use case model, the whole model, describes the system behavior from the point of view of the user, so black box, by modeling interaction sequences. Why do we do all of that? To understand the intended uses by means of the system. And how do we do it? Use cases are usually documented in a use case overview diagram plus use case scenarios. So for each use case in that overview diagram, we're going to write down one scenario description. And here I get to introduce you to a second person today. This gentleman is Cockburn. He first became fairly known for developing this use case template, which is super wide in use, and there is probably quite a few variations of it. Some companies may delete a couple of the fields because it turns out they don't really need them. Others may use the full template. Either way is good. So Cockburn, the other thing he is known for is he is one of the original authors of the Agile Manifesto. So what do we see here? We see a textual description, and then let me quickly point out the bullets to the left. So use cases and scenarios complement each other, and we can use either structured text or we can use sequence or interaction diagrams. We get to the sequence diagrams later in this course, which is why we're not doing them today. We only stick with this textual template. And the elicitation happens iteratively, which means I write down a first draft and then I'm going to have to play it out and see if this actually works. Like I'm going to walk through step by step. But first, let's walk through step by step through this template. So at the beginning, the use case, the name is the goal as a short active verb phrase. The goal in context is a longer statement of the goal in context if that is needed. So here it's good if you can refer back to some higher level requirements, and that will allow you for traceability later on. Because if later on some of your business users change their mind about the business requirements, then you have an easier time tracing that into the more fine-grained requirements if you made that link. Or backwards, when you're like, this does not make any sense to me. Why did we make that design choice? And then you can trace back to the higher level requirement where it came from. Then you can go, oh, that's why. Or you'll go, wait, like that is not valid anymore. Therefore, we can change that use case. So traceability, important topic. Not of this course, but in general, it is. So scope and level. There are several options here for what the system is being, what the black box part is. So am I talking about summary use cases for the entire system? Am I talking primary tasks? Or am I talking small subfunctions of the system? How big is my scope? And then we talk about preconditions. What we expect is already the state of the world. For example, user is already logged in. A success end condition. So what does the world look like upon successful completion? For example, purchase completed, notification sent. A failed end condition. The state of the world if the goal got abandoned. That sounds very grave. But the failed end condition would be something like process aborted or an error message. Those would be failed end conditions. And then you have a primary actor for this use case, and maybe there are also secondary actors, other systems that are relied upon to accomplish a use case. If we go back to the gas station example, the primary actor could be the customer, and then a secondary actor could be the bank or the credit bureau. And then there is a trigger. The trigger is the action upon the system that starts the use case. For example, customer approaches cash registry. And then we go into the description of the individual action steps. And here you see two further breakdowns. One is called extensions and one is called as subvariations. So after you describe your action steps, step 1, 2, 3, here we go, you get to talk about the extensions. Remember the extension use case bubble on the right? That's where you can stay. At step 4, there is a branching condition. If customer has luggage, then include the name of the sub-use case for check-in baggage. Or if it's just a single other instruction that needs to be done, then you can just put that instruction right there as the action. That is one way, or that is one part of it. And the other part are the subvariations. So after the customer approaches the checkout, the cash registry, they can tell the person at the register whether they want to pay for fuel or whether they want to pay a lottery ticket, or maybe both. So wherever it branches off into subvariations, that's where this part goes. Wait, rewind one step. I just said whether they want to purchase a lottery ticket or pay for fuel. Those were actually two different use cases. That was a bad example, scratch that. So subvariations would be for the use case, purchase a lottery ticket. If I want the Golden Globe ticket, and then I have to go through a number of steps, or if I want the Red Rooster ticket or whatnot, then I may have to go a different route because both of them have different steps for the lottery tickets. I am clearly not a domain expert on lottery tickets, forgive me. But you get the idea. If there is a branch and we go different paths before we go back together, then that's a subvariation. If you have one continuous line of action and there is one extension over here, one path that you could choose in addition or not, then we're talking extension. Okay. And then there could be some further related information. And that is fairly open what that might be. So any other use case that might be helpful to relate to something that is in a very close context with this one, where they may influence each other, that might be helpful to note down here. And then there's a priority. How critical is this use case to your system or organization? And then there's a performance attribute, which is the amount of time this use case should take. And then there's a frequency. How often is this expected to happen? And then we come to channels to actors. So they could be interactive. They could also just be a static file. They could be a database. They could be a timeout. When they go to systems, users hopefully don't time out. Maybe sometimes if they just walk away. And then there can be open issues. So list of issues awaiting decisions affecting this particular use case. And then there's a due date when that release is planned. Further management information as needed, and then superordinates. So if I have a hierarchy of use cases, then I can put the higher use case into the superordinate. And if I have subordinate use cases, then I can link to those. This also depends on what kind of tools you use. This can be super useful in a case tool environment, computer-aided software engineering tool, where when you click into your use case bubble, you get to the sub-use cases. There, an adequate linking of the use case descriptions is equally important. Okay, that's quite a bit of a template. Let's see, let's look at which words should we use and which words should we not in those use cases. And then we'll look at an example. So a lot of the time we have some UI details that maybe want to sneak in because as a software engineer, you already have a couple of ideas of how that could be implemented. Because we're still on the black box level and we only talk about the what, not about the how, we're going to try to avoid all user interface related words. So instead, we say what is happening, but not how. So use the words on the right. The system prompts, the user initiates, the user submits, the system starts, the system informs, the user chooses, the system specifies, the user selects, the system displays. Those are your good words. Stick to those. A little example here, by product. So we're just going to get started on the step description before we get to the full example for the entire template. We start with an informal description to buy a product online, and it starts with customer browses a catalog, system displays product detail. So, this is interesting. We don't only talk about the actors doing something, we also talk about the system response. This is actually the number one thing that I give as a feedback when I see a first draft of use case scenario descriptions. Usually it is, oh, you only wrote what the customer is going to do. You didn't tell me what the system is going to do in response to that. So there's always this back and forth. There is customer, system, user, system, user, system. There's always a back and forth. If I give some input to the system is going to do something with it. Otherwise, it would be really bad interaction design because I'd have no clue whether the system actually received my input if I don't receive a response to that input. And then the customer selects an item to buy, goes to checkout. This would pretty much be like a one buy click, because otherwise I would have to say that the system puts it in the shopping cart. But we're going on the shopping cart page, and then the customer fills in the delivery information. System shows full pricing, including shipping. Customer fills in credit card details, and then the system authorizes the card, confirms sale on screen, and sends an email to the customer. So if the system does several things in a row, that's fine, as long as we can show that to the user. I would be irritated if I entered several commands and have not received an output on my first two commands when I enter the third command. But if we know what the system is going to be doing and it just shows us click, 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 card authorized, confirm sale, and on the back end the email goes out, perfectly fine. So how are we going to keep those steps concise? Because I can be telling you a lot of stories about that web shop, and then it would just be a way too long narrative. For that, we use a glossary. And glossaries are sometimes like glanced down upon of like, oh, come on, like we know what we're talking about. we don't need a glossary. And then 3 stakeholder meetings down the road, you're like, wait, I thought personal details were just weight, age, and height. Now you're telling me that we're also supposed to keep their feelings from the last session, or their shoe size, or their whatnot. Don't matter. So it's super useful to have a glossary, and I would suggest to get that started early on with your project. And that will help you keep your use case descriptions shorter, because you can refer to the entries in the glossary. Here with the example of personal details. So we don't have to list all the personal details that should be stored. We can just refer to the glossary entry. There are a couple of optional steps. We already briefly talked about them. So the descriptions also cover alternative courses and the triggers that initiate their execution. There is an alternative course if the card fails to authorize in that web purchase. So at step 8, system fails to authorize credit purchase, and then the instruction is return to step 7, allow customer to re-enter credit card information, retry authorization. Good. Alternative dealt with. It's an alternative because it branches. So here was your successful path of credit card gets authorized, and here was the branch of you got to go back to step 7 and re-enter credit card or do something else, and then you hopefully get to the same outcome. Let's check another example. Book a course place. So the admin clerk retrieves scheduled course details. That's our main scenario to start with. 2, system displays number of places free. 3, admin clerk chooses add delegate to a course. 4, system requests delegate details. 5, admin clerk enters delegate details. And 6, system stores details and confirms. This is the very plain scenario that we're starting with. And now we're going to look at a couple of options of how that path can still be changed. One of them is there are no more free courses available. Step 1 is the same. Admin clerk retrieves the scheduled course details. But then number 2A is system displays no places are free. And so instead, the admin clerk searches for dates with free places, and the system displays those, and then the admin clerk selects a date. And then we can go back to the main path, the main course of this scenario, and continue with step 4 in there. Another one would be that there are details missing in the course. So when the system requests a delegate, not in the course, in the database. When the system requests to delegate details in step number 4, the admin clerk enters the ones that are known, and then gets a message by the system that says reservation is conditional on full details, okay? And then the admin clerk can click okay, because they know there are some details missing, they don't have them available right now, and they take the responsibility for this. And then we continue with the main scenario in step number 6. So just as a brief, more generic overview or schematic overview, an outline captures use case steps in short sequences, and they're organized sequentially. And this is the largest part of the Cockburn template. At the beginning, you have kind of the context information. At the end, you have the additional attributes. And in the middle, you have that main outline. And this outline has all the steps numbered, the basic flow, and then you have the alternative flows and you have subflows. So you have your extensions and your variations. The precondition that I briefly mentioned, just a tad more detail on that, is an assumption of the system state when the use case starts. It's a simple, clear, logical statement explained with predicate math notation. Potentially, doesn't have to be. The example that I gave you earlier was the user is logged in. It should be verifiable, and it should not refer to prior use cases that have been carried out, just the state of the system. For example, when I have a use case measure distance, then a precondition could be that the distance is set to 0 currently, because measuring a distance only makes sense when we start at 0. Equally for the post conditions, a post condition describes the state of the system after the use case, and use that when the system state is a precondition to another use case, or when the possible use case outcomes are not obvious to use case readers. So for the purpose of this course, we'll always write the pre and the post conditions because we want to train our minds to be able to identify those. In practice, they may or may not always be used. I'm trying to teach you to be very thorough, because the other part's going to happen by itself as you either are in a rush, or as you need to go towards a deadline, or because the company that you'll be working for has a slightly reduced template. So the outcome post condition for the measure distance would be the old value added with the average speed times the measured time. That's how you get to your new distance. And then you have your measured distance of which distance that runner has covered in the meantime. Again, often it can be expressed mathematically, not always. You might also say, user successfully purchased a book. And then the use case descriptions. There are a couple of standard items that you will find in pretty much any use case template. I just like to refer back to the Cockburn one because it seems the most encompassing, and there can always be narrowed down or more specialized versions. But what you always need: name of use case, pre and post condition, purpose of the use case, description, alternative courses, and what if things go wrong. That is a case you always want to have identified and defined. Let's get to the full example of smoke detection. So we're back with the Cockburn user template. You see the characteristic information at the beginning. Starts with the goal and context, which is to inform stakeholders of the fire in the house. Good, noble purpose. The scope is the alarm system, and the level of the use case is primary task. Remember, the level was system use case, primary task, or subfunction. Preconditions for this one are, in this case, textual. They're not written down mathematical. The alarm system is armed and active. The detector is working. Communication means of functioning. Good. Success end condition would be that stakeholder is informed. Failed end condition would be that stakeholders are not informed of smoke and the fire destroys monitored property. The primary actor in this use case is the smoke detector, and the trigger is the detection of smoke with that sensor. Main success scenario is number one of the smoke detector signals smoke presence. 2, the system identifies smoke detector location by its communication port. And 3, system informs stakeholder via phone line and the AV speaker. And then we get to the related information, and that's, like I said, is optional from the template use, and I strongly suggest you use that at the beginning just to get into the practice of thinking about what that even is. Priority, top priority, yes. Performance targets, stakeholders should be notified within 5 seconds. Frequency is rarely, only in extreme cases of fire or strong smoke concentration. I'm not so sure about that. I'm looking up at the ceiling here because we were just cooking a couple of days ago, and nothing was on fire. We were just baking some broccoli in the oven and the smoke alarm still went off. Anyways, subordinate use case, notify stakeholders. The channel to your primary actor is simplex, one way. It's electric wire, it's a phone line. And the secondary actors are authorities and owners. The channel to secondary actors is phone line and speakers. Oh, sorry, shoot, rewind. Channel to primary actor, simplex one-way electric wire is from the sensor to the smoke detector system. The channel to the secondary actor, which is the stakeholder that we're trying to warn, the authorities and the owners, that's via phone line and speaker. Open issues on this one are how the system will recognize that someone is cooking food that generates smoke. There we go. No false alarm for broccoli. That is not even burned. Schedule version 1 release. So this goes out with the first release because it's the very basic use case of that system. All right. Are you ready? Almost to jump into writing your own use cases. One more example here. Slightly different layout, but same general template. So here you just see the actors and the system in like a left and a right column for the actions, so you can see the back and forth better. It's kind of like a ping pong game, and by formatting it that way, it'll be easier to see when maybe you've skipped a step of a system response or an input. And then the exceptions are also listed here. Sometimes you will find that alternative flows are phrased as exceptions. Again, goes with the template that the company you work for uses. We'll stick with the traditional Cockburn one for now, and we'll do the alternatives and subvariations. Yes, system. There we go. Now it's in red as well. So seeing those two next to each other, those two columns, can be pretty helpful. Good. How do I do this all? How do I get started? Where do I begin? We deduce the use cases from the business processes. So if we have a business process model from talking to our stakeholders and we know which external systems there are, then we can think about how to fit that into a usage model that talks about the system as a black box and how it interacts with the user. So we analyze the business processes. We talk about how the distribution to actors works. So which actor is related to which use case. We identify the usage functions and of the system, and we define the roles of the system. So the system can be just passive support, for example, data administration, or it can be an active support that carries out some task performance. Super informal to start with. What are the main system features? Long story short, what are the main system features? And for that, I need to look at the business processes. Business processes, as compared to system processes, are what's going on in the real world, quote unquote, that we're trying to support by the software system we're developing. And then we'll do a stepwise description and refinement of the scenarios and their interaction. Thereby, we'll model the information flow for the later data modeling, and we'll also pay attention to the interaction and control flow at the system border. The relation between use cases and scenarios is an iterative one. So for each bubble in the overview diagram, that use case summarizes a set of scenarios to a specific usage of the system. A use case, one of those bubbles, is a task, an objective with a causal relation. It has pre and post conditions. And a scenario is a sequence of events. It's steps, events, interaction. And you elaborate those iteratively. So we talked about refinement and abstraction, same story here. You can cluster scenarios into tasks, and each of those tasks can be depicted as a use case bubble. And for each use case, you can elicit task-specific scenarios, and then you analyze and walk through them. So you're really going to go back with your scenario description of the individual steps and walk through your system one step at a time. Okay, use it as this, system does this, use it as this, system does this. What happens in this case? To see whether you've covered all your bases. Which brings us back to the design habit. So, little reminder, experts draw the problem as much as they draw the solution. You now know that while we are analyzing the problem, by drawing elements in a use case overview diagram, we are already taking some design decisions. Like, is a use case of wash car an extension of buy fuel, or can I also wash my car without buying fuel? Those are very important design decisions, and they often get underestimated when we work with use cases, because people often think, oh, like that's just requirements engineering, we're just writing down what is. No, this is already design. Like, we're doing both at the same time, or both iteratively. So be aware of that. A little reminder of the words to use and the words not to use. So prompts, initiate, submit, start, inform, chooses, specify, selects, displays, all of those are good words. Phrase your use cases actively. And now it's time for you. So your exercise for today is go ahead and try out the use case overview diagram, and then also try to use the Cockburn template for writing down one specific use case for the amusement park ticketing and entrance system. Little reminder for the notation on the bottom right for how to do your use case overview diagram. And I'm pretty sure you can easily come up with a handful of use cases for that. And when you choose one that you want to detail, make sure you pick one that has a couple of extensions and subvariations, okay? That way you get to try out all parts of the template. Use active voice and use the role name of the actor in the description. So don't just write the user does X, write staff contact does X. The more specific you can be here, the less confusion there will be later on. I know some of the things that I ask you for sound a little pedantic or a little overly detailed. Being specific really makes it easier later on. It avoids confusion and it avoids miscommunication. So that's why it's worth just being a bit more diligent with it. And I know you can do it. Couple of hints on what to look for when you review use cases. Here's a checklist. So have you found all the actors? Have you found everybody that interacts with this system? Have you accounted for all roles in the system environment? So all other systems that talk to ours. Is each actor involved with at least one use case? If there's an actor flying around that is not connected to any use case, problem. Do any actors play similar roles in relation to the system? If so, maybe it's possible to merge them into a single actor. If they play somewhat similar roles, but some of them know more than others, then you can still use the generalization. Remember that. Is it easy to understand what the system does by reviewing the use cases? So when I read through your use cases, do I understand what's going on? The use cases, do they have unique, intuitive, and explanatory names? So you want to have active names. You want to have a verb and then maybe an object along with it. Make it really descriptive. If the use case is called administration, then I don't know what's going on. Use the verb form, administrate, patient, or whatnot. But make it active. Customers and users understand the names and descriptions of the use cases. So make sure you use the language of the domain and at a level that your users can understand it. The brief description gives a true picture of the use case, so it should be an accurate description. And each use case is involved with at least one actor. There can be several, but no use case is just floating around by itself without an actor attached. No use cases have very similar behaviors or flows of events. Why not? Well, because then they should probably be extensions or subvariations of one another and go into the same use case. Have all use cases been identified? Tricky one. How do I know? I go back and check with my stakeholders. I go back and check with all the actors. That's how I know. Can every use case be traced back to a functional requirement? Well, yes, if I have that available, a list of functional requirements. So for your exercise, I admit that is pretty short. It's like, take the ticketing system of an amusement park. There wasn't a whole long list of functional requirements. But you can elicit those use cases from knowing what an amusement park looks like and what the entrance and ticketing system can look like. And then you develop a better version of that. And then the last one, all CRUD use cases, create, retrieve, update, delete, have been removed. That I'm on the fence about. So I can see how I can always come up with like an administrator actor somewhere in the background or a maintainer that can do all these database thingies. The create, retrieve, update, delete, those are so fine granular, they can show up as a subfunction. If I make one use case overview for the main functionality of my system, those should not be in there, yes. At a more detailed level further down, when we talk a lot about subfunctions, they may show up. Good, hope that gets you ready and hope you feel that that is getting you on the way for the task of just doing one of those overview diagrams and at least one more detailed scenario, and then reach out for feedback. So in summary, today we talked about Object-Oriented Analysis and Design with Applications by Grady Booch, Chapter 1. And we talked about use cases. We talked about how to do the overview diagrams and how to do the textual scenarios. Thank you so much for joining me. Leave some comments. Let me know what you thought. Let me know your questions. And I'll hopefully see you soon. Take care.